Changing decimal number to fraction number. Before we start, please be reminded that the link to the worksheet of this video can be found in the descriptions of the video. If you like this video, please consider to subscribe to our channel and click on the bell next to the subscribe button to follow us. We are going to upload a few videos every week. In this video, I'm going to discuss how to change decimal numbers to a fraction number, be it a non-recurring decimal numbers or a recurring decimal numbers. Let's start with the easier one, the non-recurring decimal numbers. 0.6. If we would like to change this to a fraction number, that's easy. If we have one decimal place, then we divide these numbers by 10. So one decimal place, 10 here. If the number has two decimal places, then we divide these numbers by 100. Two decimal places, 20. If the number has three decimal places, then we divide it by 1000. So three decimal places, 30. Okay, how about this one? Even though this number has one digit, however, it has two decimal places, and therefore we take this number, which is 6, and then divide it by 100. Two decimal places, 20. Okay, so that's easy. How about recurring decimal numbers like 0.66666 recurring? To do this is pretty easy as well. We take this number, but this time we divide it by 9. So 6 divided by 9, and this is equal to 0.6 recurring. If we have two numbers recurring, then we take this number, divide it by 99. So two decimal places, 29 in the denominators. If we have three numbers recurring, then we take this number 613, divide it by 999. So three decimal places, 39 in the denominators. If we have four decimal places, then we divide these numbers by 9999. Let's see how this trick works. Let's say we have a decimal number, 0.6 recurring, and let's assume that this number is equal to x, and let's label this as the first equation. And then we take this equation, multiply by 10, so we get 6.6 recurring equal to 10x. Okay, so 0.6 recurring multiplied by 10, we get 6.6, and x multiplied by 10, we get 10x. And let's label this as the second equations. Okay, and these two are simultaneous equations, and let's take the second equation, subtract the first equation. So to the left, 6.6 minus 0.6, we have 6, and 10x minus x, we have 9x, and therefore x is equal to 6 over 9. So this example shows that 0.6 recurring is equal to 6 divided by 9. You can prove all the other conversions of the recurring decimals by using the same method. You can try it by yourself, okay? How about partially recurring decimal numbers? For example, 0.06 recurring. So for these decimal numbers, only one digit recurred, okay? So for this case, we take this number divided by 90 or 90. So how do we get these numbers? So we check how many digits are recurring. Okay, in this case we have one digit. If we have one digit recurring, then we have 19 digits in the denominators. Okay, and then we check how many 0 in front of the recurring digits. In this case we have 10, and therefore we have 10 in the denominators. Okay, so how about this one, 0.061? So we have two digits recurring. So two digit recurring means that we have 9 digits in the denominators, and in front of these two digits we have only 10, and therefore in the denominators we have 10. So we take this number 61 divided by 990. Two digits recurring, we have 9 digits in the denominators, and 10 in front of the recurring digits, and therefore we have 10 in the denominators. So for this case, we have only one digits recurring, and 20 in front of these recurring digits, and therefore we take this number 6 and then divide it by 900. One digits recurring, 9 digits, and then we have 20 here, then we have 20 in the denominators. So for this case, we have two digits recurring, and 0 in front of the recurring digits, and therefore this is equal to 61 divided by 9,900. 2 recurring digits, so we have 9 here, and then 0 in front of the recurring digits, and we have 0 here. Now let's see how this trick works. Let's take this 0.06 recurring as an example. So let's say this is equal to x, and we take this equation multiplied by 10. So we have 0.6 recurring equal to 10x, and let's label this equation as equation 1. And again, we take this equation and multiply it by 100. So the left hand side will become 6.6 recurring, and the right hand side will be 100x. And then we take equation 2, subtract equation 1. So equation 2 subtract equation 1. For the left hand side, 6.6 recurring minus 0.6 recurring equal to 6, and 100x minus 10x equal to 90x, and therefore x equal to 6/90. So you can use this method to prove all other conversions. Okay, you can try it by yourself.